we finished the list of studies which we had to discuss in this topic, and then we moved on to the methodologies of traffic data collection. There are three types of methodologies, which are what? Manual, semi what? Semi-automated, yes, and fully automated. Okay. So we are discussing manual. Okay, and we said that manual has some limitations. Cannot be for a long time. It cannot be for many locations. Okay. So this example which we were doing is related to counting manually. Okay. Now, who will tell me what happened here? Why we have gaps in this counting? Why we have these gaps?
Because it's 4 days, you have to engineer. So,
Okay, not engineer. You will not do.
yeah, the one collecting the data.
Okay. So we have more lanes and less people, so we are trying to manage them accurately and efficiently. Okay. So what was the first thing we did?
Changed from the 15 minutes to...
Yeah, it was 12 minutes, we converted to 15 minutes. Okay. And then we filled the gaps. How? By taking what? Interpolation, average, whatever you call it. Okay. In the end, we came up with this table. Okay. So there are no gaps now, and all values are 15 minutes. According to the question, we were required to have or do the calculation now for each direction and then for the freeway. Okay, we are required to do the calculation for each direction and the freeway. Okay, so each direction had 2 lanes, so I added the flow of the 2 lanes to get for the complete direction, and then I added the 2 directions to get it for the freeway. Okay, freeway is the type of highway we have. We call it freeway or highway, same thing. Okay. Now, the question asks to find out the peak hour volume, peak hour time, and peak hour factor. So everything about peak hour, right? Everything about peak hours. Okay. For how many hours we collected the data? 2 hours. How many hourly volumes I can have? 2? Yeah. 2? No. We can have more hourly volume. 1 hour means what? 60 minutes. Okay. So whenever we finish 60 minutes, it's 1 hour, right? Whenever we finish 60 minutes, it is 1 hour. So I can do 60 minutes starting from 4 p.m., right? I have data from 4 to 5. Let me finish. Can I finish 60 minutes from 4:15? Yes. I have data from 4:15 to 5:15. So this is another hour. Okay. Can I finish 60 minutes starting from 4:30? Yes, I can. This is wrong. 4:30. This should be 4:30. No, 4:30. This should be 4:30. It's a mistake. So I can finish from 4. So I can start from 4:30 to 5:30 as well. So now count like this: 4 to 5 p.m. Right? I have the data. 4:15 to 5:15. I have the data. 4:30 to 5:30. Do I have the data? 4:45 to 5:45. 5 to 6.
5:15 to 6. No.
5:15 to 6:15. Do I have the data? No. So we end here. So I can have 5 hourly volumes. 5 hourly volumes. Okay, and this is what you can keep in mind for your project as well. Later on in the project, when you will go for 1 hour volume, you don't have to start at 2 o'clock exactly. You can start at 2 or 5 and end at 3 or 5, no problem. Okay? The 1 hour is 60 minutes. Start from anywhere and anything. Clear? Here we are looking at the data. Do I have the data from start to end? That's an hour. If I don't have data, I cannot make an hour. Okay? So, now I will make it into the hourly volumes. Okay? So, I will get rid of the columns which we are not going to use. Or let me just put another slide. Okay, the columns which I don't want. Columns. Okay. Okay, so eastbound hourly volume. Then I will have westbound hourly volume. Then I will have freeway hourly volume. Okay, so the first hour is from 4 to 5, right? The first hour starts from 4 till 5. Give me the volume for each side. So we will add these 4 values. Okay, how much? Hmm? 4, 6?
0.
Okay, next one. Now you will add these 4 values. Huh? 3, 6, 6, 4. Why? There's a problem here. First one, you add these 4 values. 3, 6, 5, 1. And the second one is correct? No? 3, 6, 3, 1. Okay, next one. Now you will add these 4 values.
So we could arrange the 4
Huh?
the 4 4 3 make it 4 11.
Okay, next. So these 4 values now. Huh? Do something.
3, 4, 3.
Huh?
3, 4, 3.
Okay, now this one.
Three double one,
311.
three.
Huh?
3114.
This one.
Three zero six
306
three.
3. This one. Anyone else?
From 7:59.
Yeah. This.
No.
Correct?
Two nine six
296.
four.
Okay, now for the freeway, what will you do? Do I need to still add 4 values?
The first one is 3631.
This one?
No. The eastbound. All the first
36?
31. And the second one is 3661.
Sure? Okay. And these are correct? Anybody who checked? Correct? Okay. Now for the freeway, what will you do? Freeway means total of both directions. Okay, so just add these two numbers. Don't have to add the 4 numbers here. Okay, you already have the hourly for each direction, just add them together. How much?
669.
669. Next, 6777. 7. 6753. 6618. Last. 6396. Any questions? So we needed hourly values. So each value is 15 minutes. I added 4 values, I get an hour. So wherever 4 consecutive values were available, I added them, I got an hour. Okay? Just to remind you, the first value represents 4 to 5. The second value represents 415 to 515. Third value represents 430 to 530. This one represents 445 to 545. And the last one represents 5 to 6. Okay, same here. Now they are asking for peak hour. Which of these values represents the peak hour? We started with eastbound, let's say. Okay, so for eastbound, which value is the peak hour? Peak hour means the volume would be the highest. Which one is the highest? 36, 6-4, right?
3-4 to 5.
4:15 to 5:15. Very good. So peak hour is 4. 4:15 to 5:15. Peak hour volume is the volume we have in this hour, 3664. Huh? Okay. Now, how do we calculate peak hour factor? Volume over, so volume is 3664. Over what? Huh? 4 multiplied by maximum 15-minute flow. Okay? So this value came out of these 4, right? Which one of them is maximum? 930. So how much is this? Okay, westbound, peak hour. Which one is the peak hour? 4:30 to 5:30. Okay, the volume is 3 multiplied by what? 7?
7, 9.
And this is
0.98.
okay for the freeway. Which one is the highest? This one, right? So the timing is what? 4:15 to 5:15. The peak hour volume is 6777. And the peak flow is how much? 16?
17.
No, 1723. Okay. It's 0.98, I think.
No, it's so that the one point one.
Huh?
We divide this by one.
Say, what's your question?
We put the flow itself, the hospital.
Yes.
And we divide it by one.
Where did I divide? I didn't divide by anything.
It's the same. I didn't see.
Huh? I'm not dividing by anything. The volume, and this is the flow. And the 4 was itself in the equation. I'm multiplying the flow with 4. Huh? So you multiply the flow with 4, it becomes what? It becomes what? 1 hour, right? It becomes rate of flow then. It becomes rate of flow. So it is, in the denominator, it is 4 multiplied by the flow. Then it becomes rate of flow.
But the term of peak hour of freeway, what is 4:15 to 5:15? Yeah, you want from 4:15 to 5:15. It's only 15 minutes. The range.
Because you were not there when you were doing this. Each value represents a whole hour.
Okay.
So this is, I'm just writing it because it is ending at 4:15. But I added these values. Okay, so this 6777 is this plus this plus this plus this. Okay, they are hourly. Hourly cannot be 15 minutes, right? Hourly cannot be 15 minutes. Okay. Did I answer your question? Any other question? Clear? Okay. One thing which is very good here, that you can see the peak hour is different in both directions. Okay, the peak hour time is different. The volume is obviously different, and the peak hour factor can be different. It's coming out to be the same here, but it can be different. But usually peak hour factor does not change much. So it's not like one direction has 0.98, the other one has 0.79. If one has 0.98, the other one may be 0.97, 0.96, 0.99, something like this. They will be close. Okay, peak hour factors are close to each other. But the other things, there is no rule. The time can be different, volume will obviously be different, and the peak hour factor will be close but may not be the same exactly. Here it is exactly same. Okay, but it's not a rule. Got it? Clear? Okay. So we did the second part of the question. Okay. And the third part of the question, we already did it for the peak hour. They are just asking us to do it for all the values. What is the third part of the question? Calculate directional flow rate. Calculate directional flow rate. What did we do in the peak hour equation? Where did we calculate the directional flow rate? Can somebody point out? We just did it. But we did it for one value only. Where? Flow rate. Where is flow rate in this slide? Yeah. I just told you, right? Where is the flow rate? Huh? Where is the directional flow rate value? Where is it? Where did I calculate it? It's there. Where is it? Huh? So you stop talking. Okay. Where is it in the peak factor? Which value is directional flow rate? 4 times 930. This is directional flow rate. But for peak hour factor, we only do it for the maximum value. So this denominator, 4 into something, is directional flow rate. This denominator, eastbound, directional flow rate. So in the peak hour factor, whatever we are doing in the denominator is the flow rate. It's a flow rate. Okay. So they are saying you did it here only for one value. Now do it for the entire time. Okay. So since you already know it, I will not waste much time on it. Okay. So the flow was 876 here, and the flow rate is 3504. What did I do with 876? Multiply by 4. That's it. Yeah. Okay. So all values multiply by 4 for both directions. One time for eastbound, the other time for westbound. Clear? Okay. Any question? Done? Sure. People don't believe me. My students don't believe me. Huh? But it's good. Okay. Other thing we can do manually is speed studies. Okay. For speed studies, the simplest way is you have a distance. When the car enters the distance, you note down the time, and when it leaves, you record what was the time taken, and then you do what? Distance over time. It will give you speed, right? The distance which is taken for doing the speed study We call it trap. So trap is a distance which is taken for speed studies. Okay. Another way of doing a speed study is using a speed gun. I mentioned that there is an app through which you can measure speed, right? So then when you are using the app, your phone acts like a speed gun, a speed radar. Okay? But then why we are calling it manual? We are dealing with manual studies, right? We are discussing manual studies, right? Manual methodology. If you are using a speed gun on your phone, how does it become manual? It's not manual, right? So this is wrong. No.
You were right in the paper.
You were right in the, okay.
Sir,
You are the observer. Okay. A speed gun does not operate by itself. It's like your phone. It does not operate by itself. Okay. It just keeps on giving you notifications. Okay. But if you are not there, if you just put your phone on a stand there, okay, it will not give you speed. Okay, so that's why it's manual. You are using your phone, but still you are the one who is using it. Okay, if you are not there, you will not get the data. This is the definition of manual methodology. This is what I said yesterday. What is manual methodology? Which cannot be completed without the person. So even if you are using a speed gun, your data will not be recorded without you. Okay, so still it is manual. So you can do distance upon time. In that case, you are using a stopwatch, right? And what is a stopwatch? It's again a device. But that device does not operate by itself. It does not give you the data by itself. It still is manual. Or you can do it directly using a speed gun. So using a speed gun, it still makes it manual because still you have to operate the speed gun. Okay, it's just like the surveying equipment you may have used, theodolite and total station. You still have to put the total station on the stand and do this and do that. Okay, otherwise it will not give you any reading. Okay, so you are using an equipment, but the method is manual. Okay, clear? If you are using a stopwatch, if you are using the first method, distance upon time, then there can be two types of errors in your measurement. Okay. The first one is, and both of them are systematic error. Both of them are systematic errors. Okay, so they are systematic errors, and then they are human errors. Mistakes. Any other name? Mistake is not an error. Mistake is not considered as a type of error. Mistake is something else. Random error. Yes. So there are systematic error and there are random errors. Okay. One of the error in the stopwatch method is the error of parallax. Okay, which I will explain you in the next slide with an example. But it has to do with your line of sight. You are looking at the car through your eyes, right? So your eyes can deceive you, believe it or not, even with the glasses. Okay, so the error due to your line of sight, this is called as parallax. Okay, first error. The second error is the error of operating the stopwatch. You operate the stopwatch manually, right? You have to click start and stop. Okay, so maybe your start and stop does not match exactly with the car. Maybe you were slow. Or maybe you were too excited and you did it early. The car did not even enter and you already pressed start. Or the car did not reach the end and you press stop. Okay. So this is the operation, the error in the operation of the stopwatch. Okay. But this error, if there is no mistake, like I mentioned earlier, mistake is something else. We are talking about error, something which happens unintentionally. Okay. So if the stopwatch error is happening unintentionally, then it is considered random. Okay. Random meaning what? Sometimes it will be positive, sometimes it will be negative. some values are higher than actual and some values are lower than actual. In the end, you will take an average, right? So it will do what? It will it will cancel. The negative positive will cancel each other. Okay, that's why we create none. Okay. Understood? This is clear? Going back to the parallax error. What is the parallax error? The circle at the top of the slide is the observer. This is the observer. This is the road. D is the distance he is observing to note down the time. So when the car will cross distance D, he will note down the time. Okay? Now, let's say the D is 100 feet. Okay? It's a lot of distance. So, he is looking at this point straight. But when he looks at the end point, can he look straight? No. His line of sight is inclined. It's diagonal, inclined, whatever you call it. Okay? So this creates a parallax error. What is parallax? When the car and the point show or they are shown to him in one line, actually the car is not on the end point. You see his line of sight is like what? It's like this. So on this line of sight, when the car is here, it will seem to him that the car is at the end. So he is supposed to note the time for distance D, but he is actually noting down the time for D effective. This is called as parallax error.
But how to know?
I will come to it. You got it? What is the error? You got it? Huh? I'm looking at this point from here, and this is my line of sight. When the car reaches here, okay, the point and the car are in the same alignment, right? So a person who is standing here, it will seem to him the car is here. The car is actually not here, it's here. Okay, but when his line of sight is tilted, so it will seem like clear. Okay, now what to do about it? So what do? We note down the distance from the road to the observer. We need two things. To correct this error, we need two things. We need to know the distance from the road to the observer. We call it distance D1. Okay? And we need to know the angle between the start point line of sight and the end point line of sight. This is the line of sight at the start point, right? And this is the line of sight at the end point. So what is the angle? We call it a small delta. Okay, so if you know these two things, you can correct the error. How? So let's say we were doing a speed study using the stopwatch, okay, and the trap length was 400 feet. Trap length is 400 feet. Which distance is 400 feet? D is 400 feet. Okay, he is supposed to note down the distance for, the time for D, 400 feet. Okay. The observer is lined up 60 feet away from the vehicle. So he is 60 feet away from the road. Vehicle is on the road, right? The vehicle is on the road. So he is 60 feet away from the road, D1. Okay. When viewing the exit boundary, the exit point, the sight line was at 60-degree angle. Okay, we are calling it what? Angle?
So how do you do that?
They use a theodolite light. They put a theodolite light where the observer was supposed to stop, and they measure the angle from a start point. Okay? Just trust me, there's something which we call theodolite light, and from there we can measure the angle. For the rest of the things, you are welcome to go to Dr. Nidal. You love him, right? All of you.
Yes.
Very good. Okay. Now this observer in this position, 60 feet away from the road, angle of 60 degree, he records the time 8.3 seconds for a vehicle. Now, according to him, in 8.3 seconds, the vehicle has covered how much distance? D effective. D effective. The actual distance covered by the vehicle is D effective. Okay. So I want to know the speed of the vehicle. Speed equals. You said something else, right? Distance upon time. Do I know the time? Yes. He gave me the time, right? Do I know the distance? No. I need to know what? D effective. Okay. Now if you look at the diagram, D effective equals to what? D effective equals to what? Tan? Tan, okay. Because I know D1 and I need D effective. Okay, so I will use tan. Okay. Okay, so D effective equals $60. Which 60 is this? D1. Tan 60. Now which 60 is this? And the angle. Okay. By chance, by coincidence, the angle and the distance both are equal in this case. Okay. So how much is D effective? Huh?
82.5.
How much? 82.5? So the speed will be 103.9 divided by 8.3, the time which he gave me. So the speed is how much? Huh? 12.5 feet per second. Again, this is not the question in which we have to convert the velocity. So we'll keep it in feet per second, no problem. Okay, you are doing the inverse, I think. You are dividing, right? Okay, clear? Okay. So if I increase D1, what will happen? D effective will increase, right? If I increase D1, D effective will also increase. What is happening with the error? It is becoming less because D effective is becoming more and more close to D. Okay, so you can play around with these values. You can put this equation into Excel and see which value will give me zero error, for example. You can see. Okay, you can play around with these. Sorry? Yeah, I think so. Maybe. I'm not sure about that, but D effective will definitely increase. Yeah. So when you change D1, you are changing the observer location, right? He will see both things as inclined. He will see the start point inclined, the end point inclined, if he is in the middle. Okay? Clear? Another way of doing this is keep D as short. Parallax error increases when the actual D is longer, because the diagonal will create more error then. Okay? You are looking at the diagonal, right? Okay? So if D is longer, this diagonal line will create more error. Okay? If you keep the D shorter, it will have less error.
Doctor, either we increase D1 or decrease D.
Yeah. Like I said, you can play around with these values. Now you know how to calculate D effective. Okay? So you can play around with D1 and delta to see when these values become very close. Now we can see the error is very high. See? The D effective is how much? 103.9. And what was D supposed to be? 400. 400 and 103.9. You see the difference? Okay. So you can do some things, play around with the values, like I said. There's no fixed formula that, okay, put this value and this and you will get the answer. Some things you have to keep in mind, and this is in the second task of the term project. So keep in mind. Okay. Why? The question is not about summing up. The question is about how much is the speed. He gave you some time. You found for how much distance the time is taken, and you got the speed. That's it. You can calculate the travel time. Now you have the speed. From speed you can calculate the travel time. Okay. Some things you need to keep in mind when you are doing the speed studies anywhere. Okay. In the field or for your term project or whatever. The first point is avoid the extreme drivers. Okay. People who are insane and they look like they are insane. Okay, like they are not in their right mind. They are going like this. Okay, maybe some of you. We don't take the speed of those cars. Okay, one thing which is not mentioned, but yeah, it's mentioned. So any vehicle which is too fast or too slow compared to other vehicles. Compared to other vehicles. Everybody is going at 100, 120. Okay, so the people who are going in this lane is fine. Okay, but there is someone who you only listen. Something happened. Zoom and gone. Don't worry about that. Okay, we don't want it. Clear? And too slow again. Don't want it. Why? Because they will disturb your average. That one car can bring the average down by 5 or 7 kilometers per hour. So I'm not worried about that one car which is going against everybody else. Okay, so too fast or too slow, we avoid it. Even if you got the values. Now all the values are between 80 and 100. And there is one value which is 40. But there is one value which is 140. Even if you get this value, do the calculation without these values. Exclude them. Second thing is, if you are doing it after the intersection, okay, so I told you, vehicles move in group from the intersection. They are together, one after the other. They get the chance to move from the intersection usually together. 4, 5, 10 vehicles move together. Okay, and those group of vehicles is known as a platoon. So when you see there is a platooning in your vehicles, in your cars or in your on your site, then in the platoon, who is deciding the speed? The person who is at the front. Others are still following him. Okay, so if you are just doing the study after the intersection, the real speed will be shown by the front driver. Others are just following him. Okay, got it? And the third point is, in most of the cases, like 99% of the cases, heavy vehicle speed is not required in speed studies. Okay, unless we are doing some special case. Got it? Heavy vehicles are not included in the speed studies in 99% of the cases, unless the client says, especially, I want heavy vehicles, or unless you know that I need the speed of the heavy vehicles. Then, otherwise, we don't include the speed of heavy vehicles in our data. Got it? Motorcycles, you can include them. Okay, then we have semi-automated studies. Semi-automated studies are done through portable devices. What is a portable device? The device which you can the device you can yeah, you can take it, you can carry it. Okay, so one of the most popular portable equipment is a pneumatic road tube. one of the most popular equipment for semi-automated studies are portable pneumatic road tubes. They are used in Bahrain as well. I mentioned that earlier as well. You will see like a black wire which is on the road. Okay, so that black wire is the road tube. At the end of the black wire, there is a sensor. Okay, so when the car passes over the black wire, it will record you. So the pneumatic road tube can give you speed. It can give you number of axles. What is number of axle? What is an axle? What is an axle? So this is your car, right? Okay. So you have two tires here. These two tires are connected with a rod. This is called an axle. Okay. So when the tires pass over the tube, an axle has passed, right? Okay. So the rod which is connecting the two tires. So that is an axle. Huh? One for the front tire, one for the back tire. Every set of tires has an axle. Every set of tires has an axle. There will be an axle for the front tires. There will be an axle for these tires. If there is a truck, it can have more tires, so it will have more axles.
Why is something axles not
It's a tube. It's a tube. And the tires are passing over the tube. So it can only count the thing which is passing over it, right? Got it? It's like, like if I put a sensor here, okay, which is taking my fingerprint. So I put the finger, right? So is it counting number of people or number of fingers?
Yeah, but when the car is passing, if it's two axles, it's one car.
One car, yes.
So after that, why don't
Yes, we will do it. Okay. One restriction with pneumatic road tube is it requires some manual data to do this, convert the number of axles to number of cars or vehicles. Okay. So when you are using pneumatic road tubes, there is some manual study also done at the same point. Okay. Not the whole time, a short manual study. Okay. So maybe the actual study is 24 hours. The short manual study can be for few minutes. It's enough. Why we do it? Because the road tube is giving us access and we want number of cars or vehicles. Okay, so to do this conversion, I need this manual study. Okay. So what to do with this manual study, we will see it with an example next time, inshallah. Okay, any questions? Okay, next time we will finish this topic. Okay, so maybe today or tomorrow I will send a link so you can vote for the quiz date. Okay, and you have to select from the options. Don't, like I said, don't use your brain. Just select one option.
So next week, options?
No, today or tomorrow I will send you that.
The options for next week?
For next week, inshallah. That's why I'm telling you today. Okay, only 2-3 slides are left in this topic. Okay.
The quiz will be at the end.